Swayam Prabha. Digital India. Educated India.
Welcome back. This is the final lecture in this particular course. This is lecture 60, Geospatial Analysis, part 3. And in this particular lecture, we will cover different concepts such as deep learning in ArcGIS, of course, then Python in ArcGIS using ArcGIS API, and then again we will look into implementation of Python in ArcGIS using ArcPy, and then we will give you two examples where we are getting data using Google API inside ArcGIS using Python, of course, and then again we will give another example where we will use the Overpass API, which is from OpenStreetMaps, to also get data via Python into ArcGIS. And finally, we will end with a brief information about network analysis. So this lecture actually shows that how all things that you have learned in the different parts of this course comes together. For example, we have learnt about machine learning, we have learnt about the different ways, we have learnt CNNs and other techniques. So you will see that how that is applied in the context of GIS, in the GIS platforms as well, and using this we can do a lot of analysis which are related with urban areas. So we in the last lecture we ended something with imagery analysis, and one part was over there which is deep learning, and then we are continuing with that. And deep learning in ArcGIS Pro enables automated extraction of features from imagery using AI models such as CNN and so on. So what kind of tasks are supported? Different supported tasks are like object detection, image classification, semantic segmentation. That means each pixel could be also segmented, and segment means determine what it is, what type it is, and the change detection on satellite or drone data. All these things could be done using this deep learning. Now ArcGIS provides pre-trained model, also it provides us training tools, and it allows us to integrate with Python framework so that we can also build more advanced or more customized models. So it is used for building detection, road extraction, land use mapping, different types of urban analytics and so on. So the workflow is something like we start with the image, then we have to do labelings. Labeling basically means that we create a boundary box like we did earlier also, that against that particular item that we are trying to identify, and then we will train the model to find those particular things in the other parts of the image. And you can see that this is the inference that we are getting, which is identifying the exact same thing. Maybe it's the roof of a building from that particular image, and it can directly mark, instead of manually digitizing all the buildings, the software will be able to find the building on its own, but provided of course that building is visible in that particular image. Now because of tree cover, because of certain other issues, if it is not visible or it looks almost like the surrounding the vegetation, then probably we may also lose it. So of course this has to be checked, but if it is done properly, then we can reduce our manual digitization task by a huge amount. So what we are doing over here is, this is where first we have to go over, again this is a little bit older version of ArcGIS. So first we have to do labeling of objects for deep learning. So that means we have to open an image, and within that image we have to start digitizing some part of it to show that okay, which things we are trying to find, right? So this digitizing, so suppose we are in this particular image, this is again from ESRI, ArcGIS, deep learning documentations, different manuals that they provide. So this is where swimming pools are being digitized, and it is done by using a bounding box or a polygon to create labeled training samples. So what that means, this bounding box actually tells us that this is a swimming pool, and which also ensures that there is class consistency and proper sample size. So that we have to ensure. So that means this is the first task that we have to do. The next is, of course, we can use a pre-trained model. This is not continuity, but in general, if I say, that means when we are using deep learning, then we can train a deep learning model. That means we first create those particular levels and all these things, and then using those levels we can train that particular model, or we can use a existing built up model as well. So we can detect objects, classify pixels using deep learning, and detect objects. All these things also could be done with built models as well. So this is where we are, after we have done this labeling of the images, then we are exporting the label sample into deep learning format, which are known as chips over here, and along with the metadata and the chip data, we have to save it first, and we have to set the tile size, the stride, and other information that is required. Now, if you remember, when we did CNN, we learned something called stride, right? And also we learned something regarding the kernels or the filter sizes, right? So that is what is coming over here. That is what should be the size that we are looking into at one go, and then the size of course of that particular image, that particular tile that we are considering, not exactly the kernel, but at one go we look into only some part of the image. And then stride actually is how we will move across, that is being considered. So generating image tiles, and once it is done, then we have to split it into training and validation data sets, adjust parameters like chip size, overlap, and augmentation options. So all these things we have to set, and once we have done with that, then the model could be trained. So this is where the model is getting trained. The backbone model over here is ResNet 34, and then model type is single shot detector for object detection, and then we are taking the input training data from training chips, which we just saved earlier, and the output goes into this pro pool. This one is the output model that is being generated. So once we run that, the model gets trained. The training model could be example MASCAR, CNN, or UNet by selecting backbone, batch size, epochs, and GPU settings to learn about swimming pool features. So that means you have to set all these parameters so that the model can train itself. So we have done what is the epoch, that is so many times it would be trained, and all these things. We have done this earlier. So finally, once we have trained the model, then of course we have to apply this model to predict for the rest of the area, right? So we are applying, so that's why detect objects using deep learning. So we are specifying which model that we are, the input raster we are giving, the output detected object we are giving the model definition as well, the model that has been trained, and then we can add padding, threshold, all this. When we have done CNN and RNNs, we have learnt about these things. So that padding is given so that the edge information is not lost. Threshold values we can give to determine the confidence thresholds and so on. So based on those, we can also use the trained model to also classify or find the pools in a particular image. So we are applying the trained model to new imagery to detect swimming pools, set confidence threshold, NMS, and output features class, and then we are good to go. So next, you can see that we have initially trained the model in a small part, maybe over here, or maybe the entire thing we have trained. Now we can use the entire image to do the predictions. And as you can see, after the predictions, you can see these are the points where we have found the swimming pools. So this actually shows us the number of swimming pools and also the polygons of swimming pools, or the total area. We can compute that how much volume of water is required to fill up those swimming pools. A lot of analysis could be done. So we can also evaluate detection accuracy, refine results, and use outputs for mapping or perform other statistics or further spatial analysis as well. So this is one application of deep learning, but it's not only done step by step. We can also write Python code as well inside ArcGIS, and using that also we can generate our models, we can train our models, and so on. But to do that, we need some certain other things. So next we will discuss how to integrate Python in ArcGIS. There are two basic ways. The first one is of course ArcGIS APIs, and also there is not only that, we can also use an ArcPy as well. ArcGIS in today's context, to automate many tasks, we require some amount of this support from Python or similar other programs. So that now ArcGIS provides us, and ArcGIS integrates with Python very smoothly, and so we use this ArcPy library for desktop GIS versions and ArcGIS APIs for Python for web GIS versions, right? So that means if you are developing a particular program and within that you want to call the ArcGIS functionalities, right? So we will use the ArcGIS API. But there are some issues. Some things are free, but many of the things are not free. You have to have a license. So those issues has to be sorted out as well. But this one is, when you install ArcGIS, automatically the ArcPy library gets installed, and now you can call that library again and again inside your Python code, either inside ArcGIS within a Python window or outside ArcGIS in a Jupyter notebook, and you can also do a lot of functions or tasks that is actually done inside ArcGIS. So ArcPy is used inside or alongside ArcGIS Pro to automate geoprocessing, spatial analysis and data management, and ArcGIS includes built-in environments like the Python window and the Jupyter notebooks for interactive coding. So we can parallelly put Python code, and we can see that how the output of the code in the GIS itself, and the ArcGIS API for Python whereas if we want to do it without installing ArcGIS Pro, or we want to do it from a remote desktop or something, then ArcGIS API we can use, and it connects to cloud platforms like ArcGIS Online for web-based analysis, mapping and data access. And Python enables automation, advanced analytics and integration of GIS with data science and machine learning. So ArcGIS API for Python could be used in PyCharm, any of the IDs common IDs that we have used. It could be used in PyCharm, Visual Studio, Eclipse, Spider, Rodeo, IDLE, in any one, right? So these are different IDs, IDLE, Eclipse. This we have not discussed earlier, but these are APIs where Mac, we can write code for different platforms such as Macintosh systems or Mac operating systems or Windows operating system and so on, or Android operating systems and so on. So, there is a little bit of overlap. So, what we are doing is we are importing the GIS module first. So from ArcGIS.gis we are importing GIS, and what we are doing over here is we are connecting anonymously first. That means we are creating a GIS object, a connection over here, GIS equal to GIS this one, and that means then what we are doing, that we are printing connected to and the exactly gis.properties.portal name gives me to what we are connecting to. So over here it is connected to ArcGIS Online. And then items equal to gis.content search. So I am trying to look into the free content that is there in ESRI, that is available there, and we are searching for population world, and we are finding 3 items which are related with this population world and so on. So this searches for public GIS content, and then for each of this item I can try to print out the 3 items that has been found. So title and item.title has been printed out. So you can see title USA soil map units, then type is a feature surveys, and then we are living in the age of humans. So all this thing, the title and the type, and both of the title as well as the type, those could be printed, right? So that means what? That means we are connecting online platform which is ArcGIS Online, and we are getting data from that. Now we can also import some maps from there, right? Or we can import some functions from there. So this is just an indicative program. So but it shows you that how we can integrate GIS in a normal Python program. But the most likely thing that you are going to use Python within ArcGIS is to make sure the ArcGIS can do a lot of work in an automated mode, or it can do a lot of repetitive tasks in a very smooth way, right? So that is why we will use Python in ArcGIS. So that is actually possible because of this ArcPy library, and this allows for the automation of data collection at a scale impossible for manual entry. That means if I want to get data for roads for a particular city, I don't need to digitize every road of the city. What I will do is I will directly download it from Google or some other website or some other service which provides us that kind of data, right? Where already that is being done, or points of interest, right? So we can use popular API services for this, right? So first, the different popular API services we have learnt earlier during this course, but again, like if you remember, Google Places API, it is used to extract points of interest like parks, schools, or transit hubs, essential for land use mapping and accessibility analysis. So if I want to understand how many number of schools are available in a certain radius, or what is the distance to the different schools which are in different parts of the city, and then we can determine the school accessibility for each of these particular wards or each of these particular zones, then we can get the data from this Google Places API. Then geocoding API is there, which converts text addresses such as IIT Kharagpur into latitude longitude coordinates for spatial plotting. So we can get the latitude longitude for each of these particular items that we are searching for, and then we can store that in GIS, and then we can also display that in GIS. And then routes API provides travel times, distance data for multiple modes like walking, transit, driving, and then it is crucial for network analysis, last mile connectivity studies, and so on. So that means instead of calculating all the times and all, we can get that from Google data as well. Because Google doesn't does it using the hundreds of Google phones, hundreds of Android phones. Google actually can get the data and it determines that if a person is walking, what is the time required to traverse that particular link in that particular network, or if there are vehicles, how much time it takes. So it considers many things and it can do very accurate predictions. And we don't need to do actual service for this, we can just get those data directly. But of course, if you use Google API, you have to create an account and you need to set up a Google console to receive API key, and you may have to pay. If the amount of data requested is large, then you have to pay a significant amount of money. Whereas for standard mapping work, we usually use Overpass API, which is a popular open source choice. It is the read-only query API for OpenStreetMap. That means you can just read the data and you can build. You cannot change it over there. So you are querying the data, you are getting the data back. You get specific map objects such as roads, buildings, bus stops, parks, hospitals, or point of interest based on location and tags. So it can be extracted instead of downloading an entire map. So we can only extract the things that we require, and we don't have to pay anything for that. So this OpenStreetMap data or Google data, whatever the case may be, then we are sending a query and we are getting the response back in GeoJSON, JSON, or XML form. Again, from Google API also we get it like that. Then the GIS software, actually we need to store that in the GIS software, so we need to do some conversion, and then we can do further analysis with Python and so on. So we are using Google Maps as the data source, Python for processing, and ArcGIS for storage and visualization. Now coming to Python in ArcGIS, we will focus on ArcPy because that is the most common usage of Python in ArcGIS. So you need to have ArcPy, of course, and Python script could be used to extract points of interest from Google Maps API and convert them into ArcGIS feature classes inside a GeoDatabase. GeoDatabase is the database that if we have to create that database, right? When we are bringing data from Google API and we need to store it, we need to store it in a database. Within that, there will be tables as such. So we can open the Python window within the software itself, and the steps would be like we connect to Google Maps API, we search the point of interest like malls, park, temples, we extract the attributes from there, we convert that to a data frame, and then this data frame could be stored in ArcGIS after we create a feature class, and within that class the data gets stored, and then we can then of course when after the class is created, we insert the points into GIS and then we can visualize it. So ArcPy and Python enable automation of GIS workflows, reducing manual efforts and errors. It supports batch processing of large spatial data sets efficiently. So that means we can give a lot of commands together and we can do it repetitively. Then it ensures reproducibility and consistency analysis, because again and again I'm not doing it manually. We are just repeating the same commands again and again, and it allows integration with data science, machine learning, and APIs. Why? Because we can do coding in Python, we can do a lot of analysis in between, and then we can store the data after the analysis. And it can help us build custom, scalable, and advanced spatial analysis workflows. So this is an example of the script that we used to extract data from Google using Google API, and this data was to extract the point of interest from the central vista in Delhi area, because we had one project where we are supposed to do some installation work in the central vista area. So that's why we need some point of interest data, like we want on commercial feature what kind of point of interest. We want the tourism point, the commercial leisure points, the government offices, the private offices, the roads, the parking aid locations, the vacant spaces, all these things we require. So import, of course we are starting the code with importing ArcPy, importing Google Maps, importing Pandas SPD, import JSON, import OS, and from datetime also importing datetime. So first we have to configure, and this is where we are configuring the API access. That is, we have to set the API key, because Google will not allow you access without an API key that you have to generate in the Google console. And then we specify the study area, that is in Delhi NCERT we put the lat long, and then we also put a search radius of how many meters. That means from that particular lat long, for how many at what radius we are searching for this point of interest categories. So what are those POI categories? I just mentioned heritage tourism. Within that, tourist attraction, museum, churches, Hindu temple, mosque, synagogue, art gallery, aquarium, zoo, landmark, all these things are included. For commercial, electronic stores, clothing store, department, supermarket. Then for leisure, park, amusement parks, bowling alley, casinos, all these things. Government offices, fire station, local government office, police, post office, embassy, courthouse, everything is included. And vacant, and similarly parking, roads, vacant spaces, all these things we are also getting. Now the output directory and the output GDB has to be specified. That means where we are storing the database and where is the directory that we are putting all this. We are it is recommended to use absolute path, of course, instead of giving the root like we are doing in Python earlier, so that it finds the location properly. And then we are also doing in this particular program, we are also classifying the roads as well, such as highway and motorway are considered as primary roads, trunk roads are also primary roads, and secondary is then there are secondary roads, tertiary roads, residential roads are local, service roads unclassified, then there are some unclassified roads. So now we are defining some functions in the program. The first function is to initialize, create the connection to the Google Maps API. So this is where we def initialize underscore gmaps underscore client, we give the API key, and then you can see that the Google Map gmaps equal to Google Maps dot client. This is the command which actually creates the connection, and then we can print Google Maps client initialized successfully, and then we can also do some exception handling, such as if there is some error, then also that could be printed. The next part is to fetch do the searches for malls, parks, offices, and return JSON data. So that is the next function, def fetch places from gmaps location radius. That means which point, which lat long, which radius, and what are the place types that has to be given. And so we are doing that over here. So already we have mentioned which are the points of interest earlier. So that is what we are passing over here, and we are seeing whichever points are being considered, those are sent, and we are sending the query type, and we are getting those particular things. And then we are also doing this classification function, where we are classifying the different roads based on its particular category. And finally, we are converting the raw API data into structured table, and so that means the JSON format and all this, whatever way we get it, we are making a table with name, latitude, longitude, rating, and so on. And this is one of the most important parts, where non-spatial JSON is converted into spatial geometry. So that means we are saving the latitude, longitude. Over here we are extracting the latitude, longitude of those particular areas over here, and then what we are doing is also we are doing this extra classification, road type, parking type, depending on what is being what is we are getting over here. And next, after we have done that, then we remove duplicates, and finally we create the GIS layer inside the geo database. Now this is where we are doing that. So this is the function def create feature class. This actually creates the this creates the GIS layer inside the geo database, but this create feature class underscore management, then the GDP path, which is the database path, the FC name, point, spatial reference, all these things actually help us in creating that particular GIS layer. So the layer has got place ID, then business status, road class, and something called query type. Those are the ones which are getting stored. Finally, insert, we are converting each row into a GIS point. That means every row of data that we have entered, that has to also be given a spatial location. So we have that obviously. So this command actually does it with arc.py.da.insert cursor. Then we can, for every value, we can insert the longitude and latitude, and then this insert cursor function used to write new rows into the GIS table, so that we are giving them we are giving it a particular location as well. And finally, these are the different functions that are covered. Finally, we call the main function, and this is the main execution. And you can see the different. We are first creating a connection, and if not, then we are creating a new connection. If it is searching for that, if it is not there, then it creates the database. And then for different items and all, it fetches the places first, and then it extracts the place data, and then it creates the feature class where all this becomes part of GIS, right? All the fetch data using this Google API becomes part of the GIS layer that we are creating here. So this is the example. Over here you can see the sorry. So here we are running the code. You can see the code running at the bottom, and it is searching for the places, and it found 20 places. You can see what it is all those is coming over here. And so this is the Python window where we are running the code, and again it is how many places are found for each cat RV parks. It is finding one, and once it does that, then once all the searching is over, then it will start creating the GIS within the GIS database that we are creating. Then it will plot it as well. So it's processing vacant space. It is finding 20 places, and finally the map comes, and you can see all the spots are being, all the points of interest are plotted over here. Each is given a different color depending on what type of feature it is, right? So what type of point of interest it is. And so this is the central vista area. You may remember, you may have already seen that in maps earlier. So this is how we are able to extract the different point of interest using simple Python code in the GIS software itself. So this is how it looks like. So we are getting vacant in the map, vacant spaces, parking places, road places, office private places, all the different things are there. Each comes in different layers, and on the right hand side you can see the code that is there. The API key is blacked out because we have bought it with money. So the rest is the code that I have already shown you. Now, next we will give you an example of Python in ArcGIS, of course, but with overpass API, because it is difficult in to get the roads from using Google API because of money issues and other thing. So, but it is freely available from OpenStreetMap. So, that is what we have done. For the same area, we have extracted the road features using this OpenStreetMap, and then we are plotting it in our GIS. So, you see over here we can actually get data from multiple data sources and we can combine them inside our own GIS database. So, that is the beauty of it, and the underlying logic, everything remains same as Google Places API. API key is only not required in this particular case, and overpass API is open source and it is best for extracting road layer that are crucial for network analysis. So, this is where when the code gets executed, this is how it is working on it. That means parallelly we are coding as well as we are automating the entire task of digitization. In today's context, there is no point of doing all these things manually, because we have already created the map layers in different softwares or services that is already available. So, we don't need to do extra work, and you can see at the end of that we get all the roads that are there. All roads are marked now inside our GIS map. So, that means the entire thing has become now automated. Now, the final one that we will discuss is network analysis. This is not where we are using Python code or anything. This we have if you are really interested in this, you can look into our NPTEL land use transportation lectures, where we have discussed network analysis in detail. This is just to show you the power of GIS or this kind of software, where we can do a lot of network analysis as well. It is used to analyze movement and connectivity over a network, like roads, transit, utilities and so on, and we can solve different routing problems, accessibility problems, logistic problems using network analysis. And we can do route analysis to find the shortest path between points, or how different points could be connected together, then service area analysis, then closest facility analysis, then origin destination OD cost metrics, vehicle routing problem we can solve. That means if a vehicle has to reach many points, and it may have some constraints, that what is the size of the vehicle, what it has to carry, it is going to pick up something, deliver something. So, we can solve all those things, and it will give us the optimized route for those particular vehicle. So, all these problems we can solve. Just to give you an idea, So, whenever we are doing network analysis, we have to start by building the network first, right? And once we have built the network, then of course we have to depending on what we are trying to do, we can put some points or locations where we are trying to determine shortest paths or something that we have to put in, and after that we have to also decide, is it based on walking or is it based on some other mode, and that also we can specify. Like for example, here it is, you can see that is given as driving, or we can change it to walking, of course, and then it will be based on the walking speed and all, right. So, once we have done that, then we can run this path analysis and so on, and then we can see that, okay, and you can see the number of those points which are generated over here, and then we can specify the shortest path or the shortest route network connecting all these points and so on. So, different kinds of analysis could be done, but the idea is first we have to generate the network, then we have to do the points, we have to create that what is the travel time in that network, we have to put in those kind of data. The network analysis layer has to be created for that, and after that we can actually do the network analysis, where we can show that, okay, what are the different, actually this is where we were trying to put in some bicycle sharing stations and all, and then we were trying to find out the paths connecting those particular stations. So, that is what we have done it, and you can see that at the end of this analysis, we would be able to generate the paths, the shortest path connecting all these particular stations, right? So unnecessarily we don't traverse on path, which will actually increase the time or the fuel consumption for vehicles used for carrying bicycles to those particular points. So this kind of network analysis is also part of GIS analysis which you can undertake. So this is a final reference. These are the references you can study use. And to summarize this particular lecture, because now that we have come to the end, we can say that urban informatics integrates IoT sensors for real-time data collection, SQL for data management, Python for processing and analysis, machine learning for intelligent insights or predictions, and GIS for spatial visualizations, creating a comprehensive data-driven ecosystem for smarter and more responsive urban planning. So, of course, it is not everything of urban informatics. Urban informatics also means building larger models, doing predictions, building simulators and many other things. But like it is basically amalgamation of all these different technologies which makes this particular subject very interesting and also very relevant for the coming future. Thank you.